So there's a really interesting statistic that I found that says if you put a certain number of people in the same room and ask each person what their birthday is, there's a higher likelihood of two people sharing the same birthday than you would initially think. So if you count leap year, there's 366 days in a year, 365 in a normal year, right? So once you get up to 366 or 367 people in the same room, you're guaranteed to have a duplicate birthday. But statistically, if you just put 23 people in the same room, there's a 50% chance that you'll have a duplicate birthday in there somewhere, which blows my mind because there's 365 days in the year. And with 70 people in the same room, it goes up to 99.9% probability. And the probability means if you do this test, 100 times in a row, in half of the groups, you're going to have duplicate birthday, and the other half you won't. So I wrote a little bit of code to test this because I was curious. I always wanted to test this. And so I have a function. You tell it how many people are in the room, and it basically keeps track of, for each person, it creates a random birthday, picks a number between 0 and 365, and then it looks at this list and says, have we already seen this birthday, yes or no? If so, return true, meaning we found a duplicate birthday in this group of people. If not, add this new birthday to the list and then keep going. And it does this loop. If you pass in say there's 23 people, it's going to do this loop 23 times. So it's going to assign each person a birthday, and as it goes through, it'll say, have I seen this birthday before, yes or no? If so, we have a duplicate birthday. If we get through all 23 people and have not found a duplicate birthday, then there was no duplicate birthday. So that's all this function does, is check in a certain number of people if there's a duplicate birthday or not. Assigning everybody a random day for a birthday. And doing this just one time, you can see if there's a duplicate birthday or not. So for instance, if we say has duplicate birthday and there's 23 people, let's console all this out for a second. False. No duplicate birthday. Run it again. True. 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 False. And you can say that's maybe about half, right? It's happening half of the time. So instead of just doing this over and over again to try and see if it's half, I wrote some additional code that calls this function a certain number of times. So you can say we want to run this test 100 times in a row, and on each one we're going to have a sample size of 23 people, and we're going to keep track of how many trues and how many falses we get. Okay, so each time there is a duplicate birthday, each time that function returns true, we're going to increase this by 1. Otherwise, we'll increase false by 1. So at the end of this for loop, we've tested 100 groups of 23 people, and we'll see how many are true and how many are false. And all this does is basically puts that information on the screen. Okay, so let's run that. And 55 of those 100 groups had a duplicate birthday with 23 people per group. Okay, we could run this a couple times, and you'll see that with just 100 people, you can end up going, a couple in the wrong direction, or not the wrong direction, but you can get 2 more on this side than on this side, and it's easy to skew the percentages that way. So let's increase this to 10,000. If we run this test 10,000 times, sorry, there's a jet flying overhead. I had to shut the window. So if we run this test 10,000 times, then we can see what the likelihood is for each one. Okay, so we got 51% of those ended up being true. So it's about 50-50. Run it again. 50, 49. Okay, so we get about 50% likelihood there with just 23 people. That blows my mind. The other part of the statistic is with 70 people, you end up with 99.9% probability. Meaning if you have 70 people in the same room, you are almost guaranteed to have a duplicate birthday. Look at that. 99.96, 99.86. So you can see it's right around that 99.9 mark, and it will be every time. And this engine sometimes, if it's running that many times in a row, sometimes it thinks that there's no end. All right, so there you go. That is, the computer is doing this test 10,000 times in a row for us, so we don't have to. But that's really cool. You can see that statistic is actually very true, and that's pretty cool to me.